right. I will be going every single operation and notation in basic mathematics. This is all. Got it? Good. I'll be going through every single one and explaining how it's used. Let's start with something simple. Simple addition. It's with a plus sign. You add the values on either side of it together, and you get your answer. It said 1 plus 2, or 2 added to 1. Next, subtraction with the minus sign. It's the opposite of adding. The value after the minus sign is subtracted, or taken away from the value preceding it. This can be said 5 minus 2, 5 subtracted by 2, 2 subtracted from 5, or the difference of 5 and 2. Next, multiplication with the times sign. This is also repeated addition. Generally, you add the number on the right, and the number of times you add it is the number on the left. Although, in truth, it doesn't matter which one you use, as you'll get the same answer. Feel free to use it whichever way makes more sense in the moment. This can be said 2 times 3, 2 multiplied by 3, or 2 groups of 3, or 3 groups of 2. There are also more ways to show multiplication, like with the dot, an asterisk, or parentheses. In fact, if two separate numbers are next to each other, multiplication is the assumed operation, unless otherwise stated. Next, division with the division sign. Division is the opposite of multiplication. It results in how many times the number on the right can fit inside the number on the left. The result is not a whole number if it doesn't fit perfectly. This can be said 6 divided by 3 or 6 divided into 3 equal parts. Division can also be shown with the slash or with the horizontal bar. The horizontal division also implies parentheses, and it can also be stated 6 over 3. Parentheses, shown with the open parentheses and then the closed parentheses, is a tool used to clarify the order in which you do operations. Everything between the two parentheses is done before any intermediate value interacts with any operation outside. However, that doesn't mean the value as a whole can't interact with outside operations. When you ask about the quantity, that means you should put parentheses around the quantity. So this can be stated 6 times quantity 2 plus 3. Parentheses next to another value or quantity implies multiplication between the two or more quantities. And again, large bar fraction implies the quantity of the top divided by the quantity of the bottom. A few other notation also have implied parentheses. Next, negation or negative, also often shown with a superscripted minus sign. The classic minus is also used. This generally means the opposite of. With the basic arithmetic, it is essentially -1 times, but has other uses. For example, in set theory, it means everything not included in. It is important to remember the negative sign is on the same order as multiplication when determining the order of operations. A mnemonic for order of operations is PEMDAS. So normally you would go left to right. First you do parentheses, then exponents, which I can cover in the future, then multiplication and division, then addition and subtraction. Next is some of the different ways numbers, especially non-integers or rational numbers, can be expressed. The three main ways are fractions, mixed numbers, and decimals. Fraction is just the number as a rational expression. There are two types of fractions. Proper fractions have a bigger denominator than numerator, and so are between 0 and 1. Improper fractions is everything else, when the numerator is bigger. Mixed numbers is a way to express improper fraction as the sum of a whole number and a proper fraction in this notation, with the whole number then the proper fraction. Finally, decimal is just mixed numbers, but the denominator is a power of 10. This is useful because it forces fractional components to behave like whole numbers. Each digit a factor of 10 off. Although some numbers can't be fully represented as a finite decimal. For example, 1/3 is 33333 over 1000000, so a repeating portion of decimal is represented with a bar, as shown. A final note, A negative sign applies to the entire expression, not just the first part, unless it is specifically expressed otherwise. Next is equality, shown with the equal sign. This is used to show that two expressions on either side of the equal sign are exactly equal. This means that if the same operation is applied to both sides, the two results will also be equal to each other, although they may or may not be equal to the original two expressions. The way it's stated is that 1 is equal to 1 in this case. And also, equations can be true or false. So a true equation is that 1 is equal to 1, but a false equation is that 1 is equal to 2. Often accompanying equalities are variables. Complicated equalities can often be simplified to reveal the value of the variable stated explicitly. Something like the variable x is equal to 5. Variables are usually represented by letters or symbols. However, there are also constants, which are represented the same way, but are fixed at a certain value. The most common are pi and e. Pi, which is a Greek letter equal to approximately 3.14, and e, an English or Latin alphabet letter, equal to approximately 2.718. Variables, in contrast, are inherently flexible and vary for each equality. There are also ratios, shown with the colon symbol. It can be used in place of a fraction, but can also be chained together consecutively. Generally, it establishes that things are proportional with the said ratio between them. There's also percent with the percent sign. It operates similar to decimal, except a whole is 100% instead of 1. And gaining and losing percent might seem a little confusing. Gaining 20% is 100 plus 20% equals 120%. Losing 20% is 100% minus 20% equal to 80%. However, 80% of 120% is not 100%. Instead, it is 96%, which is 0.8 times 120%. Note where there are implied parentheses. All right, thank you for watching, and I will be posting future notation and operation rules.